Folks, as Archana already mentioned, that we have different projects that are currently active in Open Compute project. But for my talk, I'm going to focus more on open system firmware. I will also talk about what OpenRMC is. It is the Open Remote Manager Controller. And I'll explain in my next slides about what exactly OpenRMC is. And also, I will touch upon some of the networking projects that we have within Open Compute. And what exactly do I mean by ONL, ONI, SI? I think something is wrong with the... All right, so I'll keep going because I have so much to cover and I have only 20 minutes. But again, if you have any questions about these software projects and about deep diving into what exactly I mean by that, please feel free to reach out to me after my talk is over. So what ONL is, ONI is, SI, and Sonic, I will explain more as I go along. And that would pretty much it. So open system firmware. And I know Steve asked a question about how many people are from softwares. I think this set is more of a software folks sitting here, right? So how many people know about firmware? So quite a lot, so that's good. That makes my life a little easy. So that also means that you guys know what BIOS is, right? That's pretty self-explanatory, right? So let's talk about firmware from the data center perspective. As you guys see here, the rack designs are getting so much complicated, right? And in the rack, you have so many piece parts in the rack. You have servers, you have networking, you have PDUs and whatnot, storage, power supplies. So there are too many things going on in a rack. So let's try to explain rack from two components. One is from the control plane angle, and one is from the data plane. And I'll tell you what exactly I mean by that is. When I say control plane, it means that you need something that controls the rack. What controls the rack? Networking is one part where it transmits the data from the rack to the outside world and so on and so forth, to the top of the rack switches and whatnot. And data plane. Data plane is something that does the magic. What I mean by magic is something that does some processing, right? And from the rack perspective, what is the device that does the processing? And one of the devices are your server node right there, right? It does some processing, right? Now, from the server perspective, there are so many different piece parts in a server. You have so many devices in a server. So many things. And every device that constitutes a server has a firmware. Even a power supply has a firmware. Because you need to have those components talk to your hardware, right? And eventually it has to be reflected to the top level. So many different firmwares. And we have BMC firmware, and of course, now when I talk about BMC, you probably already know Sai Dasari, who is right here, and Archana already introduced to Sai, and I don't have to introduce him again, but he's the one who leads the OpenBMC project from the Linux Foundation perspective. So for anything related to the firmware for the BMC, I would highly recommend you guys to reach out to him, and I'm so glad that he accepted my request to be here and address any firmware questions that you guys might have. All right, so far, I guess you guys are understanding what I'm saying, right? Because my mission is to make sure that what I say, you guys get it, and that's all, right? So many firmware. We have I/O firmware, SSD firmware, M.2, and blah, blah, blah. See, one of the firmware that is of interest is the UEFI firmware. So how many people understand what UEFI firmware is? couple of them, so that means I don't have to dig deeper. So that's fine. So traditionally, when we say firmware, what do we mean by it? We mean BIOS, right? So when we talk about BIOS, UEFI is one of the BIOS implementations. Let me put it in that way. And there are so many implementations that we have it as of today. Microsoft have their own implementation. Facebook have their own implementation. Google has their own implementation. So things get pretty confusing, right? So you have so many implementations. Which one should I use? Going to the next slide is what we are trying to do from the open compute perspective is you have so many options to boot your device and choose the right OS that you would like to boot it from the underlying system. What we as an OCP organization, they are trying to create a module that will select the boot flow based on your needs. So that will really make the life much easier, right? Because now you're not dependent on one flow. You have an option to choose from. So right now, I think it's a correct statement if I say that right now, system firmware is pretty closed. And what I mean by that is, right now, you guys have to talk to the IVVs and the vendors and get the source code and compile it and maintain it, right? Custom BIOS, things like that. So it gets very frustrating. It's because you literally can't do much because you get the code from the BIOS vendor or from the different IVVs, and you just can't do any prototyping work because you don't know the inside out of the firmware, the code. You cannot do any conceptual testing because you just cannot add your own routines into the code that you get from the vendors. So it's so much limited. It's hard. So I think there is not much innovation going in there because it is closed. And that's one of our goals is to make it more open. We want to innovate in having your firmware more open and giving a flexibility to the customer to pick based on their needs. All right, so got it. I'm sure you guys are attending or have attended many summits. Open Compute Summit is one of the summits, right? Or many other summits, and related to the data centers. You see so much of hardware. And hardware keeps changing. Every 6 months you have a new hardware. Every couple of months you have new servers. Server keeps changing, keep refreshes. So the technology is booming from the hardware perspective. And the nucleus of every server is what? Firmware. So firmware is lagging behind, but your hardware is moving at a faster speed. It doesn't seem right. So that's what I mean by here is we need to catch up. From the firmware perspective, we need to be more open. We need to open the code, let people decide what flows works better for their infrastructure. So I think that's pretty much it for the open system firmware. We call it as OSF or nickname. So I'm going to go pretty quickly. We have some key companies that are participating in this OSF opportunity. There are many more, but I have listed the ones that are really the core contributors, and they are. I don't have to go through the names, but you guys know it. And I think Archana mentioned in one of our slides that, okay, before I go there, I'm sure you guys know what GitHub is, right? Clear case, GitHub source control system, where we have our own GitHub account where any source code that is being contributed to Open Compute, we have a place where we store the source code. And we have a pretty strong governance around it, meaning that we have certain policies that we have to adhere to contribute your source code. And there's a DCO format, meaning a certificate where you want to make sure that this code can be redistributed, blah, blah, blah. I'm not going to go in much detail. And we have bi-weekly calls, and people from different companies, they participate in that. So this is going at a much faster rate. But in a nutshell, it's a firmware group, how to make it more open. So that's pretty much it from the OSA perspective, and let me talk about RMC. RMC is the Remote Manager Controller. It's another project that we started many months ago. And so what inspired this project? So remember, earlier I talked about servers. You guys are understanding, right? Okay, please stop me, because I want to make sure that you guys are coming here on Saturdays, best use of your time. So I'm trying my best to go in, in a pretty high level to make sure that you guys get it. So from the server perspective, I talked about OSF, which manages your server, but we have a couple of other initiatives going on, and one of that is that OCP is designing different rack and power, so we needed an infrastructure that could manage the whole rack, not just one server, right? So this is where RMC come into place, where there is some firmware, something that will manage your whole rack, not just one server, right? So this is what RMC is trying to solve that problem. I'm not going in much detail again because this is a little deeper, but the idea here is that we need a firmware, we need a device, our management device that does some logic. And if you look at here, on your left side, we call this as the north-facing APIs. On the right side is the south-facing APIs. And what I mean by that is that you have a firmware that does something, and on the south side of it, what you see is we have all the hardware that is located, like compute, GPUs, and whatnot. And on the left side, we use, which I call it as the northbound APIs, and that is the place where you have a data center information system, which what we do is, using some orchestration software, it will talk to your RMC manager. So you have a software right there, and here you are through different protocols, through different orchestration software, you're trying to make some calls to find some information, and then your RMC manager will then again leverage the protocols that are on the south side to talk to the respective hardware devices and to get the information that is requested. So the key takeaway from this slide is that we use different protocols on the north side. We use different protocols on the south side. If you look at the north side, we use Redfish, Anybody, you guys know about what Redfish is, Swordfish is, what profiling is? All right, so one, and I see people saying no, so few of them are still there. So have you guys heard about DMTF before, the standards body? So think in that way, there is a standard body that defines some parameters that manages a server. And then you can manage your servers as well as you can manage your storage devices. So these are the ones, Redfish and Swordfish, they manage the server and the storage profiling. So let me stop right there, but you get an idea, right? And on the southbound side, we of course do the same. Before I go there, see, on the left side, we have the legacy RESTful APIs. I'm sure you guys know what the RESTful APIs are, right? You use that and try to communicate with the RMC. And on the south side, of course, we use IPMI, which is a very low-level communication protocol, and of course, the I2C2, along with the same protocols that we use on the right. So we give an option to the user to pick what protocol works better for them to talk to the RMC. So the reason why I mentioned this slide is this gives an opportunity. See, we already have these 3 racks within Open Compute. And without any upfront cost, you can literally deploy your firmware solution in any of these 3 racks. So there's no upfront cost. You just have to develop it and put it into some device. So on the left side, we have the open rack, and you can pretty much have RMC loaded into a PowerShelf. You guys know PowerShelf, right? Okay, so currently we do have one partner, Schneider, and they have contributed their PowerShelf, and and they have a, the firmware that actually already works, so we can literally change that code and make it more BMC ready, the RMC ready. And same with the so there are different rack options. The middle one supports your switch. You can install your RMC onto the switch, and you can pretty much make that rack RMC compatible. And another option. So there are many options, but the point is clear, right? You're just putting your RMC in those racks, and you can manage those racks. All right, so the next is the OCP networking software. We have 4 networking software projects that we actually manage it on a daily basis. ONI, Sai, ONL, and Sonic. And I won't go into much detail because my next fellow speaker, he is Gopan Nair from Mellanox, is going to talk more detail about what that software is. But let me quickly touch upon those things. Your ONI is an open network install environment, and what it does is it basically gives you an installer that you can use it to install. It has an installer command. It can do a lot of things. Using this ONI, you can install multiple OSs, with one SKU. Your life gets much easier for the admins. For the Sai, going for the next one, Sai, it is the switch abstraction interface. And so what it is it's the ASIC. It provides the standardized C APIs to program the ASIC. So I'll keep moving because I have only a few minutes left. So another one is the Open Network Linux. It's the Linux distribution for bare metal switches. And the key takeaway from this slide is that we do have a GitHub account, and we do have the source code, and where any new changes or the new driver that come in, we keep storing that information into this GitHub location. All right, so in a nutshell, we have Sai as the underneath layer, and then we have Sonic, and I will just not talk much about Sonic, and I will let Gopan talk about Sonic. And there are different tools that you can use to manage that infrastructure. And I think Steve already mentioned that we have folks, the networking folks here, so please feel free to reach out to them and get more information. So the last I have is the project Zipline, and the key thing here is the data is growing in leaps and bounds. And just look at the numbers. I don't have to literally go in much detail, but if you look at the 175 zettabytes, it means that if you have one CD with minimum capacity, you need, in order to have a full, you need to make a full circle of the Earth, you need so many CDs to come closer to 175 zettabytes, meaning that the data is growing at such a faster rate. So we have quick things to look at. The chart speaks for itself. The compression gains for different logs. Using it's a compression technology. Zipline, it compresses the data into a much more compressed format. And look at the compression ratios. Whether it's the system log file, it is the IoT file, and if it is the system log. So look at the numbers; it speak by itself. So this is the next thing which is coming in, where you have so much of data requirements, and this literally can compress your data, and for the edge devices or the locations, you can, it's a great, solution for that. So, so use cases, you can leverage this for these workloads, these use cases, and these are the partners that pretty much are contributing for this Zipline project. So that's it. I have it. And I know I jumped on many slides, but as I said, I'm out of time. But if you need any information about these things, please feel free to reach out to me anytime. So that's it. Thank you, guys. Dhanyawad.